My dear students, in this video I am going to introduce a new topic, scalar product or dot product of two vectors. Scalar product or dot product of two vectors. That is our topic, scalar product or dot product of two vectors. Suppose A and B are any two vectors acting along the direction of OA. A vector acting along the direction of OA and B is a vector acting along the direction of OB. O is any horizon. O is horizon. A and B are any two vectors and theta is the angle between the two vectors A and B. If A and B are definition of scalar product or dot product, this scalar or dot product. A definition. How to define scalar product or dot product? If A and B are any two vectors, then their scalar or dot, then the scalar or dot product is defined by scalar or dot product is defined by A dot B. A dot B equal to modulus of vector A. A dot B is defined by modulus of vector A and modulus of vector B. Mod of vector A and modulus of vector B and cosine of the angle between the two vectors A and B. That is cos theta. Theta is the angle between the vectors A and B and cosine value of theta is multiplied with modulus of A and modulus of B gives you the dot product of two vectors or scalar product of two vectors A and B, where theta lies between 0 to 180 degree. Theta lies between 0 to 180 degree. First and second quadrants itself, 0 to 180, 0 to pi. Therefore, definition of A dot B is mod A mod B into cos theta. It is the definition of dot product of the two vectors A and B. You should put a dot in between A and B and you read it as A dot B. A dot B is called scalar product of two vectors A and B. Note, the scalar product is a scalar quantity. A dot B scalar product is a scalar quantity. That's why it is called scalar product. Scalar quantity, that is nothing but it is a real number. So dot product of two vectors gives you a real number. Otherwise, it's called scalar quantity. That's why it is called A dot B or scalar product. Now, scalar product and theta is the angle lies between the vectors A and B. A dot B, some results you have to remember. A dot B is mod A mod B cos theta is positive. A dot B is positive if the angle theta is acute. Acute angle. If theta is acute, A dot B is positive. A dot B is negative if theta is obtuse. A dot B is negative. A dot B is negative if theta is obtuse. Obtuse angle. That is, suppose this is theta. Theta is obtuse. A vector acting along OA direction. This is A vector and this is B vector and theta is greater than 90. Obtuse angle. In this case, A dot B equal to mod A mod B into cos theta. It is obtuse. Cos of theta is 180. It is in the second quadrant. Theta is obtuse. So in this case, cos is negative. Therefore, this is mod A mod B minus cos theta, because theta is obtuse. If theta is obtuse, A dot cos theta is negative, therefore this is minus of A dot B. Negative. So A dot B is negative value, now negative scalar or negative real number, if theta is obtuse. If theta is acute, A dot B is positive. That is first case. Next, actually if theta is exactly right angle, if theta is 90 degree, what we will see? What is the answer? If theta is not acute and not obtuse, it is a right angle. If theta is 90 degree, that case, if theta is pi by 2 or 90 degree, theta is pi by 2. What is the case? This is vector A and this is vector B, and theta is 90 or pi by 2 radian, 90 degree. In this case, A dot B equal to mod of A into mod of B into cos 90. What is cos 90? You know cos 90 is 0. Because cos 90 is 0. Therefore, this is 0, because cos 90 is 0 value. Cos of 90 degree is, cosine 90 is 0, therefore A dot B is negative. So A dot B is 0 if A and B are perpendicular. This is the case. If A dot B is 0, then vector A and B are perpendicular, and vice versa. Converse also true. That is, if A and B are perpendicular, A and B are perpendicular, then the dot product A dot B is 0. The reverse converse is also true. If A dot B is 0, A and B are perpendicular. If A and B are perpendicular, then A dot B is 0. Converse is also true. So this is, if theta is 90, A dot B is 0. This is another case. Now, if A and B are parallel, what do you get? Next one. If A and B are parallel case, in this case theta is 0 degree or pi degree. So if A and B are parallel, then theta is 0 or pi. So in this case, A dot B equal to mod A into mod B into cos 0. Cos 0 is 1. So A dot B is mod A into mod B. If A and B are parallel, if theta is 0. If cos theta is pi, it is minus A dot B. It is theta is 0. And A dot B equal to minus A, minus of mod A into mod B, if theta is pi, because cos 180 is minus 1. Therefore, this is minus A dot B. If A and B are parallel. In this case, A dot B is A mod B. Cos 0 is 1. Cos phi is minus 1. Therefore, it is negative A dot B. Okay. Next one. A dot A. What do you get? If A dot A. A dot A. In this case, mod A into cos 0. Angle between A and A is only 0. Therefore, cos A is the only vector. Therefore, A dot A is again on the same line. Theta is 0. Cos 0 1. Therefore, you will get mod A into mod A, that is equal to mod A square. So A dot A is mod A square. You remember this, A dot A is mod A square. Next, these are the results you have to remember. Next, angle between the vectors A and B. Angle between the vectors A and B. See, you know this is theta, A vector, origin, this is B vector. So this is theta. Angle between A and B is theta. It should be calculated in the anti-clockwise sense always. Theta should be measured always in the anti-clockwise direction. Therefore, A dot B is, you know, A dot B is mod A mod B into cos theta. From this you will get cos theta equal to, you bring this A dot mod A mod B to the left hand side, you will get A dot B by mod of A into mod of E. This is, from this you can determine theta. Whether theta is obtuse or acute, cos theta equal to A dot B by mod A into mod B is the result for finding the angle between the vectors A and B. To find the angle between the vectors A and B, this is the formula for finding the angle between the vectors A and B, that is cos theta equal to A dot B by mod A into mod B. From this you will get theta equal to cos inverse of, from this you can get theta equal to cos inverse of A dot B by cos inverse of A dot B by mod A into mod B. From this you can determine theta. And properties. Next one, A dot B equal to B dot A. The reverse multiplication is also possible for dot product. A dot B equal to B dot A. So B dot A you consider in this direction, in the clockwise direction. B dot A equal to mod B into mod A into cos of, in the reverse direction, clockwise direction, if you consider, angle is minus theta. It is positive. Clockwise is, anti-clockwise is theta positive, clockwise direction theta is negative. So B dot A is clockwise direction, angle should be measured in negative direction. Therefore, cos of minus theta, you know, cos theta. See, this is, you can write this mod B into mod A is mod A into mod B. Mod A into mod B. Cos of minus theta, you know, cos theta. So it's again A dot B. Therefore, A dot B equal to B dot A. A dot B equal to B dot A. So this is called commutative property. Commutative property, commutative property of dot product A dot B equal to B dot A is positive. Next, associative property. Associative. Yeah, it's not distributive property. X property, distributive property. It is A dot B plus C equal to A dot B plus A dot C. Like that it is distributed. A dot B plus A dot C. This is called distributive. A dot B plus equal to A dot C, A dot B plus A dot C. And next idea, dot product or scalar product of ijk unit vectors, mutually perpendicular unit vectors. That we will see. Angle between the vectors, you have to remember the result. Cos theta equal to A dot B by mod A into mod B. Next, one important idea, dot product of mutually perpendicular unit vectors I, J and K. Dot product of mutually perpendicular unit vectors, dot product of mutually perpendicular unit vectors I, J and K. What is the dot product of mutually perpendicular unit vectors? You know, I, J, K vectors are mutually perpendicular. I is a vector acting along the direction of x-axis. J is a unit vector acting along the direction of y-axis OY, and K is the unit vector acting along the direction of Z, YZ axis. So this is, you consider in the anticlockwise direction I dot J, J dot K, K dot I. Like that you have to consider what is I dot J. I dot J is mod I into mod J into cos of angle between I and J is mutually perpendicular. They are I, J and K are mutually perpendicular. Therefore angle between I and J is pi by 2. So cos 90 is 0. Therefore 0 and everything is 0. Because I and J are perpendicular, their dot product is 0. Cos 90 is 0. Similarly, J dot K. J and K are perpendicular, therefore their dot product is 0. K dot I. K and I are perpendicular, their dot product is also 0. I dot J. I and J perpendicular, I dot J 0, J dot K 0, K dot I is also 0 because K and I are also perpendicular. And by the previous property, dot product is commutative, therefore I dot J implies J dot I. J dot I is also 0. J dot K, K dot J is also 0. K dot I, reverse, I dot K is also 0. I dot K is also 0. So I dot J, J dot I are 0. J dot K, K dot J are 0. K dot I dot K. In the clockwise direction also, dot product is 0 because they are also perpendicular. In the reverse direction, it's also perpendicular, cos of 90. Okay. Next, same dot product of same vector, I dot I. Just now you know I dot I. A dot I is A square, you know. This is mod I square. I dot I is mod I square. Mod I, you know, unit vector 1 square. Therefore it is 1. Mod I is 1. Therefore 1 square is 1 because I is a unit vector. Similarly, J dot J is also 1. K dot K is also 1. So I dot I 1, J dot J 1, K dot K 1. Same vector dot product 1. The opposite, other vector, opposite vector. I mean same vector, I dot I, J dot J, K dot K are 1. Otherwise they are 0. If one vector is different from the other vector, then dot product is 0. One vector is different from the other vector, then dot product is 0. If the vectors are same, then dot product is 1. This is the idea of dot product of three mutually perpendicular unit vectors I, J and K. See, these are the very important idea. These are very important ideas to solve the problems, to find the dot product of two vectors. For example, consider the vector A vector is I vector plus 2j vector minus k vector. B vector is 3a vector minus j vector minus 2k vector. I want dot product of these two. A dot B. A dot B vector is A vector is I vector plus 2j vector minus k vector dot 3a vector minus j vector minus 2k vector. So dot product of two vectors in their components. A is I plus 2j minus k. B vector is 3a minus j plus minus 2k. So you know I dot I 1. I dot I 1, therefore 1 into 3, 3. I dot j 0, I dot k 0. You need not write. Similarly, j dot I 0. J dot j is 1, therefore plus into minus minus. J dot k 1, 2 into minus 1 is minus 2 only. J dot k is 0. Similarly, k dot I 0, k dot k 0, you only get k dot k. Because k dot k is 1, minus into minus sign. If you first to see the sign, minus into minus plus. And then k dot k 1, 1 into 2, 2. So this is answer is 3. This minus 2 plus 2 cancels out. Therefore, A dot B dot product is a real number. I told you already. Dot product is a scalar quantity or real number. So dot product of two vectors in the components is you should just taking multiplication with I dot I, J dot J, K dot K terms only. Rest of the terms are 0 because I dot J 0, I dot K 0. Like that. Using this idea, I am finding the dot product of two vectors given. It's a scalar quantity. So I will stop here. That's all about this idea about scalar product. Next we will see the geometrical representation in our next video. Thank you.